Hello, everyone. A very warm welcome to all of you joining us online today. We are incredibly excited to have you here for this special hands on workshop organized by GDG Visit. Our motto for today is simple: we have written the code, now it's time to ship it to the world. A lot of times we build amazing projects on our local machines, but they just stay there. Today we are changing that. This is a completely beginner friendly hands on session where we will go from writing a backend API on a local machine to deploying it as a live, publicly accessible service on Google Cloud, all without managing a single server. We are going to learn terms like containerization with Docker, serverless deploys with Cloud Run. Speaking about the perks of today's session, free swags for all attendees. Yes, every single attendee who stays here, builds and participates will get exclusive Google Developer goodies just for being present. And top 3 premium goodies. We will be selecting the top 3 most engaged participants based on your hands on activity, interaction in the chat, and completion of the deployment. The top 3 will win a premium special goodies kit. Speaking about the today's speaker, we have a fantastic speaker with us today, Harshavardhan Khamkar. Harshavardhan is the tech lead at GDG Visit. He is an incredibly accomplished developer, a winner at ETH Global New Delhi, and a winner at Google Cloud Agentic AI Day. He has a ton of hands-on experience with cloud infrastructure and modern backends, so you are all in excellent hands today. He will be guiding us through this entire journey. So over to you, Harshvardhan.
My name is Harshadan Khankar. Uh, so let's start with our workshop that is Code to Cloud. So before beginning, I'd like to ask, uh, it's an open question. What do you know about APIs? Anybody? It is free for all. Anyone? Integrate outside things with our own website and APIs like a messenger between users request and server database. Yeah, exactly. Ayush, you're right. Suja, you're also right. So, an API, in its full form, it is Application Programming Interface. So, why do we need this API? So, right now, suppose I have two programs. Say this is program A and this is program B. So, one team is working on program A and another team is working on program B. And they like to communicate or transfer data from one project, one team to another, or from one product to another. So, there might be more discrepancies, like product A is coded in Python, product B is coded in JavaScript. So, there might not be a perfect tunnel to transfer data from one side to another. So what do we do is we expose a certain interface such that program A or product A can interact with product B and vice versa. So these points where they interact, these are called endpoints. So uh, like there are many APIs. We have web APIs called as the REST APIs, representational state transfer, or even we have local APIs like OS level APIs, database APIs. So, has any one of you tried Android development or any, uh, or even Flutter? No. Okay. So, yeah. So when we build an Android app, we don't directly access the camera. We try to use the camera API, which then gives us the permission to get the camera features. So your app isn't directly accessing the camera, but it is rather using the camera API. So why do we need this APIs? The first and most foremost point for having APIs is security. So you don't want to give unauthorized access of your database to someone else, or they might just uh, do some stuff like dropping the database, and that might not be beneficial to you or your company. So what do you do? So you give an specialized access to people such that you monitor what access you want to give. So specific feature to add the stuff on database. So you give only the access of adding, and also the tables that their own that is of their own data. So you are not getting someone else's data, but you are querying your own data. So that is the foremost important point of having APIs is data security. And then the mentioned points like interoperability and smooth transition between data. So we will cover REST APIs in this uh, session. So what is REST API? REST API is, in its full form, representational state transfer API. So these API work on the internet. They have the web access, and foremost they use the HTTP and HTTPS for data from one point to another. And the most uh, used format for transferring data is JSON, JavaScript object notation. So you all must have been familiar with it is structuring your data in a easy to understand format, in short. So let's see how a REST API is. So uh, this is the API that I have created. I'll show you using, if you guys are on Linux or Mac, you can use uh, curl commands. If you don't have that, you can use Postman. And even if you don't have Postman, you can use VS Code uh, to just a second. VS Code to use Thunder client. So Thunder client is basically an extension that yeah. So Thunder client is basically an extension that enables you to query APIs. So this is one of the so this is the interface of Thunder client. I'm using Thunder client. You can just in VS Code extensions you can just search Thunder client. But this, here is uh, you put your API URL or the point through which you interact with the programming. So I'll API and I'll paste here, and then I just so I've created a point that enables me to check whether my function or not. So I'll put a get request. So I'll come. I'll tell all the CRUD that we can perform using REST APIs. So I'll just uh, the headers aren't important. It is just a GET request, and it will process. Yeah. So as you can see, it is giving an OK status. That means my REST API is working perfectly. And in the logs also, I can check it out. Yeah. So as you can see, I made a GET request, and here in the logs also I can check. So that was about REST APIs. So now let's talk about the different methods that you can use. So we are all familiar with CRUD operations. Do you guys know CRUD operations? Create, read, update, delete. So I'll assume all of you are new to this topic. So CRUD operations are basically the four main operations that you perform while uh, changing states of any database or any variable. So create is basically adding new uh, information or a new knowledge to your database. Read is just extracting the required data. Updating is basically you want to change some entry, or you want to change the state of some variables or information that is already there in the database. And then delete is just deleting any table or entry. So in REST APIs, we have four main operations for the corresponding CRUD operations. That is, post is for creating, get is for reading, put is for updating, and delete is for obviously deleting. So right now I did a get request that is just reading the API. Then let's talk about. I can also we can also see other APIs. Like I want some movie API. I guess it was UMDB API. Mm, but they need API key. Let's move on. So let's talk about the architecture of REST APIs. So just a second. I can't seem to see the chat. I'll just rejoin. Just a minute. I'll just change my internet. Hello. Yeah. Uh, I think it is fixed. I can see the rest of the chat. Okay. So let's talk about the architecture of REST API. So in my first year, I was introduced to Java, uh, and there we were taught about uh, uh, MVC architecture, the model view controller architecture. So in that architecture, we had a separate component. Model was for determining how the data or how the schema of the data would be, like how the structure of the data that you want to store would be. Then view was responsible for showcasing the required data, like your UI components, uh, your UI or your graphic components for representing that data to the user in any format was responsibility of the view component. And then there was the controller that acted as an intermediary between the model and the view component. So the controller was responsible for gathering that data, then for processing it, and then for structurally storing it in the database, and also passing it to the view model for representation. So here we have a simple controller service repository architecture. So the controller is basically the uh, HTTP edge. So the endpoint is done by the controller component. So it parses the input like uh, uh, I had, yeah. So if I do a post request, I'll be having some fields that I'm passing to the API to get some response back. So the validation of those input data is the responsibility of the controller component. Oh, I am not sure what's my bad. Yeah. So the controller component, as I mentioned, is used for parsing the request, validating the input, and then also for returning the output. So here I made a post request to my API that we will discuss further while building uh, our API. So I'll in a post request I send some data for processing. So this is the text field. This is the number of cards that I want to make and certain parameter. So it is the responsibility of the controller component to handle all the requests input that is being given to the API. Is it valid or not? And it is to be determined by the controller component. Then there is the service component. So service component is basically the controller part of our MVC architecture. So all the business logic, all the processing is done in the service layer. So suppose in our case, we'll be creating a flashcard app. So in this, what we have to do is create a flash. So we will input certain information to the API, and then API will give us the structured flashcard in a JSON format. So uh, calling the Gemini API, then processing it into a nice and cleaner JSON is all the necessary functionality of the service layer. And then at the end is the repository layer. It is basically a substitute for database. Right now in our workshop, it is too expensive to move around with databases. So we have reduced it to in memories storage. So that is where repository comes in. It is basically a temporary storage of your data. Like you had some processing with the APIs, rather than permanently storing it to the database, you're storing it for some time because as because REST APIs are stateless, so there isn't any state as such maintained by the APIs. They are stateless. So to have some processing, we need some sort of memory in local machine. No, 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 not in local machine. It is for the server side only because see, uh, I I called the Gemini API. It returned me certain things, but right now I am not storing it anywhere. But I need it for further processing uh, in my API itself, in the working of my API. But for that temporary storage, we will use repository. So it is basically a temporary storage. That's all. It's nothing to beat your head around, but it is like storing certain things for a certain amount of time. So then let's talk about Docker. I hope REST API was clear to all of you. If there are any doubts, you can ask me. Okay, nice. Aditya, you got it. Okay, so let's move on to the main part of our topic, our session, that is Docker. So all of you must have created a app or any product or participated in a hackathon with your teammates. Most of you must have, right? Yeah, yes, Ayush. Okay. So you must have faced that issue where you are coding certain things and then when you push it on GitHub and your friend pulls it, even if he does the npm install, but certain things aren't working. You don't know why it isn't working. You try to find every solution, and then you hit a barrier, and that is like it might be your friend is on a newer version, like he's on Python version of 3.14 and you're on 3.13, and certain dependencies aren't compatible with the newer version because they are being deprecated. So, and then you think about what is this issue, man? You have to you tried everything, and then you need to downgrade your system or you need to swap certain systems in its whole. It is a waste of time. I know you all might have faced this issue. It is prominently called as works on my machine issue, actually. So yeah, so this is where Docker comes in. So let's talk about what is Docker. So uh, in short, Docker is a tool where we package our app in an isolated environment, and we can run that uh, package anywhere on any software. It is independent of any platform and it will work consistently. So you don't have to change any configuration. Once you have built your app in your development environment, you can use the same app in your testing and your production environment. So Docker helps you in doing that. And also, if you are working in a team, in your company, and suppose a new person joins in, they might have to configure their system, installing all the dependencies, installing all the required packages and tools they might need to use the software. So Docker can help that. You just need to configure a Docker file and just tell your new teammate to run a command that is just Docker composer, and uh, all the development environment is directly configured in their system in a jiffy. So that is how Docker helps in solving those problems. So in a nutshell, can you please explain Docker again? Okay, yeah. So basically, Docker is I'll 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 try a different way. Okay. So there are three types of virtualization. One is uh, bare metal. So bare metal is basically you're using a system and you're uh, doing all the things on your own system. So I'll use an illustration. So this is my computer. So this is the level zero of virtualization, that is bare metal. Okay. So there is one OS, there is one storage, and there is one memory, and there is one processor. So all the things that you do, all the processes you do are done by one kernel. So platform for developing and shipping applications you build. Yeah, actually, that is a nice explanation. Okay, so this is level zero of virtualization, that is bare metal. Then there comes another format that is called virtual machines. So, uh, have you guys used AWS or Google Cloud for running instances like EC2 or Google Compute? Okay, yeah. So in there you must have had the option to configure your own OS for the instance, right? I'll show you. Create an instance and store it. So here I can choose my own operating system. So what do you guys think? They must be having separate devices with each operating system installed, or how must they be working with so many different OS? Yeah, Ayush Srivastav, you are right. Actually, those servers are independent. They're actually coded in Linux, but at the end they are using a hypervisor. A hypervisor is basically a tool that you can use to uh, install virtual machines on your computer. So your OS might be on Linux, but using those virtual machines, you can emulate different OSs on your own kernel. So uh, you can use Linux on a Windows or even a Windows on a Linux by using virtual machine. So there is a famous tool called as virtual box actually. So virtual box basically you download this and then you get a OS file of different OSs. And after installing that, you can run any OS on your computer. But your computer uh, has to use its own resources. So this is a resource extensive process. It is just used when you need to emulate or you need to use different systems that are compatible with your software, but your OS isn't the same one. So you emulate your OS basically. That is uh, virtual. And then there comes is a container where it is independent of your OS. You can run instances by Oracle. Yeah, right. So you can run instances uh, of your containers. So if this big box is your PC, your own PC, okay, and these are all containers. So your PC has a lot of processes. Okay, so I'll show you the running processes. So these are all processes running on my PC. So my kernel is managing. The kernel is basically uh, the engine of OS. So you will all learn this in the operating system subject you might be having in semester 3 or 4. So in short, kernel is something that orchestrates or controls all the processes in your computer. So what a container is, in short, is a process. Like these are some processes. A container is also a process that is running in your PC. And these processes are controlled by your kernel. And in those processes, you have your separate isolated environment that is running the application in its own sandbox. So in this container, there will be all the dependencies. There will be all uh, the OS systems and all. But the main difference between VirtualBox, virtual machines, and container is how resource extensive VirtualBox is. Because if I run a Windows VirtualBox in my PC, it might need at least 8 GB of RAM, 8 GB of memory for it to work. So my PC will split all the memory between the VirtualBox and my PC itself for my own task. But a container will work in a much lesser memory restriction. So a small Docker instance can run in just 112 megabytes. It is that uh, resource efficient. So, uh, so that was a container in short. So basically, Docker is a tool that helps you build this container. So these containers can be deployed anywhere in a production environment or in any PC, independent of the software. Docker uh, orchestrates all the dependencies. You just need to build a simple txt file that is called as a Docker file, D capital and everything small. So this is what a plain Docker file looks like. So I'll explain you what this is. So basically, uh, here I am importing a pre-built image. So you can think of it as an inheritance. So someone has built a Python image beforehand, and I am just importing that because I don't need to reconfigure all the Python instructions for a file. Someone has done that. I'm just saving my time, and then I specify this is the version. So same is the smallest version, so it will hardly take 80 MB. So there are few different versions. There is Slim, there is Alpine, then there is uh, I don't know. I'm just familiar with this too. Then this command that is work directory. So work directory, yeah, before anything, a Docker file is a layer-wise structured form. So the below every line is a layer in itself. So any changes in the layers below won't affect the layers above. So if I recolor my app or if I change any uh, code in it, so as you can see, I have attached all my code in this line. So I have already installed my dependencies first and foremost. So if I even change my code, it won't affect the dependencies. And then I have configured the port in itself. So let's talk about a Docker file first. So firstly, you need to input if you want a pre-built image, then you need to specify what is the working directory. So a Docker image itself creates an environment. So in that environment, it knows what to uh, do. So these are the instructions we are specifying. So work directory is basically specifying that my app folder is the working directory, and all the things that the Docker file needs to do should be constrained to this folder itself. Then it copies from my local machine to the Docker image is the requirements.txt. As you can see, it is not in my app folder. That's why I have specified it before. And then I run a command, that is pip install requirements.txt. So no cache is basically that I don't need to install pre-built cache. It is just used to save some storage. That's all, and nothing else. Then what I do is I copy my code from my local storage to my Docker image. So that is where I copy the app, that is this app, from my local code to the Docker image, and then I specify the environment. And this is the command that the Docker image will by default run. And this is the command that is used to run this code. So even if so, it is just like I am I am running my code in the local storage, local environment. Basically, that is the same instruction that the Docker image will do while running in an environment. So here, as you can see, if I run this command, this code will start and the server will start. So yeah, as this has started, so this is the command that enables Docker image to know what to do. So then I have explained what Docker is, why do we need Docker, what different types of virtualization. Can you explain Docker image? Yeah. So Docker image is basically a file that is generated by Docker when you run a Docker file. Think of it as like an exe file. You run a game, right? So you run while running a game, you need to start an application that is an .exe file, right? So Docker image is basically that exe file, and Docker file is a set of instructions that Docker knows to create a Docker image. So if I run Docker compose for this Docker file, it will just create a Docker image. I hope I have cleared it out. Yeah, is it clear or you want me to try in some different way? Okay, okay. Yeah. So that was about Docker. Uh, I've covered different types of virtualization, the difference between container and virtual machine. Then I've also explained uh, Docker image itself. So yeah, that was Docker in a nutshell. So yeah, reproducibility, lightweight isolation, Docker file. Yeah, 6 lines of code compose. Yeah. So um, to there is a service called as Kubernetes. So Kubernetes is basically handling all those containers and orchestrating their workflow uh, in a cloud service. So that is the work of Kubernetes. So you can explore it if you want. Uh, I won't cover it in this session. Then there is cloud. So most important part of our session. So what is cloud? So while creating an EC2 instance or a compute engine, you need to specify all the configurations of your system. So I want a 4 GB or a 128 MB, how many CPUs you need. It is uh, up to you that what control you need to do a certain task. Whereas Cloud Run is basically You just deploy a container, you deploy your code on Cloud Run. It will uh, configure uh, your environment or your resources on its own. It will handle all the scaling. If somehow you have huge traffic for 40 minutes, it will auto scale up. It will give you more resources for that time. And when the demand drops down, it will auto scale down. So you yourself don't need to spend your time reconfiguring your virtual machine, but you just need to focus on the code and the security uh, aspects of your APIs. So Cloud Run is basically that platform where you can deploy your code. So as you can see, I've deployed two services on Cloud Run. This is my service. So I can see all the metrics, all the logs of the service. Uh, I can add any triggers to my service. I can also modify what traffic is allowed. Do I need uh, authorization, authentication, or is it open to all public? So all those uh, tweaks on all those settings you can do. But the main and foremost is time saving. You need to save time. You just need to focus on the development process and not the uh, configuration issues. So that is where Cloud Run comes in. Is it serverless, right? Yeah, it is serverless. Yeah. So you're not maintaining anything, right? You're just deploying your code, and the server is handled by Google. Uh, there is uh, there's I think Amazon has, what is it called? Yeah, AWS Lambda. So the Amazon counterpart of Cloud Run is AWS Lambda. So that was AWS Cloud Run in short. So that I have covered the first point, that is auto scaling. When instances are disposable, you can uh, you can delete an instance, or you can configure any components of or your code as you want. And then the thing is port handling. So port handling is basically redirecting your uh, commands to a specific port. So I'll explain you in short. So this is an HTTP request. So a computer has around 65,000 ports, 65,000 plus ports actually. So you are interacting with your instance using two ports, that is HTTPS, that is via port 443, and another is HTTP, that is via port 80. So we might use a node server, right? So node server works on what port? A localhost 3000. So it works on a 3000. So your request is going to a port that isn't your localhost. So how do you redirect that request to to your main node server? So that is where the port handling comes in. So in the Docker image, as you might have seen, I had specified what port is my uh, local server is running on. So all the requests that the endpoint hits at port 80 would be redirected to the port 8080. Port binding is done in Docker. Yeah, port binding is done in Docker. Yes. And then while deploying, you just need to specify the Docker image, and then all the configuration would be handled by your cloud run services. And then cloud run just gives you an API endpoint that is this. How many you have claimed the $5 GCP credits that we had given. So you can see one, two, it copied. Yeah, it had a strict time limit of like 1 day itself. So any one of you who might have claimed it later did got the issue. I think 30 or 40 people claimed it on time in time. So they might be using that. So let's get on to the session. So today I'll talk about and I'll create a certain project that is Study Spark API AI. So what is Study Spark AI? So while okay, yeah. Uh, so while revision purposes, you might be asking your friends question like, tell me what is this? Tell me the definition of this thing. So what if you just create a flashcard and then you can display the question and you just need to answer. You just need to see the question and you answer uh, your flashcard, and then you can click on the flashcard to reveal the answer. So that is a quite uh, easy approach to just revise your for a quick revision before your exams. So how will our system work? So we'll basically create a controller. We'll create two controllers. So one is for generating the flashcard that will we will name it as generate flashcard slash generate like notebook LM. I'm sorry I haven't notebook LM. So if it is like it, then well you know what I'm building today. So we'll create two controllers. That is, first is read the flashcards and return us the flashcard JSON, and the second is the health control. That is just to check whether our API is working. So you will you will do a post request on this API, this endpoint to get the answers, and then you will do a get request on the health. So one request end to end. So this is how the process will flow like. As a student, I'll query for the flashcard generate endpoint. The controller will handle all the input data. The service layer will call the Gemini API via Gemini client. It will transform it into a JSON format, and then it will send it back to the user. So yeah, these are the four most important things that we are going to do. Input validation, it will be done in the controller layer. Then it is the environment variables. So uh, in production, you don't store a .env file on your cloud. So you pass it as a command, and it is never stored in any variable. So it is more secure than traditional .env files. Then there is structured logging. Logging is basically I had shown you the logs, right, of my API. So yeah, these are the logs. Logs are basically useful for knowing what your API is doing, uh, what your code is doing right, or is it failing. So even if in some failure, like you lost all your data, so you can recover that data from logs itself by just seeing what those logs are. So if you haven't configured uh, nice logs, you lose data. So yeah, logging is the key point of creating an API. All the processes that you are doing must be logged. It is also used for auditing purposes. And then the fourth point is the health checks. So health checks is basically checking if the API is live on. So let's start with our project itself. I'll use anti-gravity. You guys also start uh, and follow along with me. Let's create our backend. I might have created a documentation. Yeah. So I had created a documentation that I will share with you all. So you can just get the gist of what project we had created. So to save time, I'll just prompt here. Not- So first of all you need to do is start your terminal and create a Python. Okay, so I have uh, then the first thing you need to do is configure your Google Cloud CL. So Google Cloud CL application. So I will put this documentation in the chat so you can just install CLI. So if you're on Windows, you can follow this, or if you are in Mac, you can just use this command, and then you uh, then there will be yeah. So you will get a folder like this, wherein you will have to run this file install.sh, and then your Google Cloud PK would be installed on Mac. And in Windows, it is just you need to install this file, and then our installer exe will open up, and then you just have to click next. So follow these commands and configure your Google Cloud. So uh, if you want to check, you can check it by uh, running this command Google Auth, and you can see I have two accounts, and the active one is this. That is my personal account, and then you can check what projects you are using. Uh, so I am using GDG website. So uh, give me a hands up when you have installed the SDK. So we'll go ahead. And wait for you.
Hello, Harshvardhan. Yeah, yeah. Actually, you are mute. So
Oh, yeah, yeah. I wasn't okay. No, uh, so I am basically describing that I want a controller service repository architecture. Then I want to have two endpoints that is the flashcard generate and the health uh, endpoint. Then the backend will call the Gemini client and the model that I have specified. Uh, and in a structured JSON output, that is a flashcard. And I'll use a pydantic. Pydantic is basically a Python library where you specify your schema uh, about what you need. Then I want to containerize the app with uh, Docker file as well. Contain this app, so it will be easy to deploy. So I had already uh, written down the structure of the folder. So I'll just paste it. I'll just paste the prompt in. Can you give us that? Yeah, I'll just paste the prompt. Wait, I'll create a top file. Just I'll just paste it. Now we'll just let this build. So till then, I'll just show you my front end that I had built. So I'll show you what I have built. So this is what the flashcard will look. This project will look like. So I can just paste my images. I want to choose. So I can configure how many cards do I want. Do I want one word or a one line answer style, or I want a true or false, or fill in the blanks, or standard Q&A. So I'll do the default one, and then I can also include, do I want an illustration to help me determine what the question is or what the answer was by a diagram. So yeah, I'll just create the flashcard and I'll check if there are any logs. So as you can see, my traffic demand was 0. So the Cloud Run itself uh, had an auto scale down, so it's shut down. So it was shuttered down. So when I queried, it is starting up now, and then uh, it logged that it had a request for port 8080. Okay, as you can see. So this is the importance of structured logging. So you can know what the system is doing and you know what process had happened at what time. So yeah, so my cards have been created. So how Docker ensures application run identically across different environments like developer laptop and cloud clusters. So as you can see, there is an image. So you can see all my card decks. So this is how the project should look like. I haven't much focused on the front end. It is basically just displaying all the cards and all the uh, development, all the responses that the API had given. So I hope you have followed till now. How many of you had given the prompt and done something now? given the prompt on the browser. Okay. So after anti-gravity finish the uh, development, so you'll need to uh, uh, say you will need to deploy. So there are certain commands to deploy your uh, Docker file to the Cloud Run process. So I'll also share you the commands itself. So I'll type that in the chat. Region then what should I deploy to? So choose the region that is most closest to you. So I'll just use Asia South one, that is Mumbai server. So this is the command to deploy your service to Cloud Run. So when you are done with it, just run this command and you will see your Cloud Run service. So I'll just query my Cloud Run service. So I want to create a flashcard of this information. Just put it in. Build number of so 5, then I don't want any. Let's see. I oh, I just do it. Just that. Now it should go. Yeah, as you can see in a structured JSON format, the cards have been generated, and these JSON are then uh, shown in a well-structured format from the front. What to do now? Ayush, till where have you followed? Anti-gravity is done with the prompt with your okay. So all you need to do is run this gcloud run deploy command, and then it will deploy it on your cloud. So you can see it on in your services after you run this command, cloud run deploy. Okay, so uh, have you guys completed your deployment? Anyone? Okay, so let's wait for 5 minutes. So you've completed by that time. So after that, Pankaj Gupta will take a surprise quiz. So this quiz uh, is the benchmark. So the top three winners will get the merchandise. The exciting goodies that we had promised before that the top three people who are most engaged would be getting a special goodies pack. So this is when you can claim this opportunity. So don't miss out the quiz. Top three will be awarded.
Oh, hello everyone. Am I audible?
Yes.
Yes, yes. Okay. So now we will be starting with the guest. I will share the quiz link with you. Okay. So the quiz will have 10 questions. Okay. And based on that, we will be getting our top three participants. Okay. I will share my screen. Okay. So join this quiz and enter your name like the first name, second name, and the your class. So I will give you an example. So we will get to know like which class you are. Okay. Kalpana, you can rejoin and enter your name as I have given Avinash, and similar for other students. And guys, also, if you are thinking that you will do ChatGPT or any other LLM and give the answer to this quiz, so I will say that you have only 30 seconds to answer this particular question, and all will be getting the question simultaneously. So at the time, all the students will get the same question and same time. So you have a limited amount of time. So if you are trying to do that, so it's your choice. And also, if you are able to do that, we have a special system, so we can flag your tab switches. So if you do that, we can actually get to know. So don't try to do that thing. Yeah. With 30 participants are already in. Remaining in the mid, there are total 40 plus students. Aki, I will wait 1 or 2 minutes more, and then I will start the quiz. Okay. 34 students in. Should I start, or is there anybody remaining to join? Start. Okay, okay. I will start. Yeah. Let's start now. Yeah. Okay, the time is up. Okay, so we have the leaderboard for the first question. Saket, Parth, and Soham are on the top three for this question. Let's move to the next question. Yeah. Hmm. Okay, still Saket is on top, followed by Parth and Ayush. So moving on to the third question. Docker image and Docker containers. Oh, now Parth is at top, followed by Saket and Sakshi. Yeah. Next question. So here you have to select two options, okay? Or can be more. Let's see. Oh, Parth is still at top, followed by Soham and Ayush. Next question. Oh, Parth still at top, followed by Soham and Hardik. Uh, Sixth question. I made both of you. Great. We have still the same top three. But other students, you have still time. There are three, so four more questions. Oh, now Soham is at top, followed by Hardik and Abhishek. Soham, first year student. Still, we have the same top three. Now we have remaining two more questions. Okay, so give your best. Oh, now Hardik is at top, followed by Soham and Abhishek. Now it's time for the last question. So let's see who are the top three. Oh, so we have the leaderboard here. So top three are Hardik, Hinduja, Soham, Saran, and Yash. Okay. Uh, so in the comment section, Hardik and Yash, can you also send your class? Have you have not mentioned here, and also give us the feedback how you like this. Okay. So we have shared a feedback form in the email. So give the feedback at now only. Okay, and also tell about your experience about the overall workshop and the session, how it go, and especially the quiz. How can you receive the recording? We will sharing the recording in the WhatsApp group also, and in the event page also you will get. Okay, yes. Congratulations to all the top three. Okay, as I have mentioned earlier, we have got the participants who have cheated. So you want to see who all cheated? Anti-cheating. Yes. Okay, show names. Anti-cheating. Two alerts detected. Hardik. Yash. 50 seconds. Tab switches. 10 tab switches. Oh, Yash, what's your answer to this? Hardik, two alerts. I think two is fine. And yeah, what do you think, guys? We should reevaluate. I was not switching to meeting to see result. Okay, okay, yes, that's fine. Same here. I was checking anti-gravity. Winners are doing cheating. No, no. Okay, oh, we have the same top three only. We are not doing anything here. See my search history. Okay, okay, that's fine. View reports. Good. Okay, I think Ayush, you can conclude this session. Yeah,
Yeah, can I share?
yeah, yeah. You can share. I will stop sharing.
So, guys, it's time to conclude. This is profile of Harshvardhan Khamkar. You may connect him on LinkedIn, and he's a very nice guy. He will help you for your queries. And so, thank you. And a feedback form will be shared to you. Please do fill that, and yeah, you may leave then.